Welcome to this comprehensive guide on the tangent of some formula. This powerful trigonometric identity allows us to find the tangent of the sum of two angles using only the individual tangents of those angles. The tangent of some formula states that the tangent of a plus b equals the sum of tangent a and tangent b, divided by 1 minus the product of tangent a and tangent b. This formula is incredibly useful when you need to find the exact value of the tangent of an angle that can be expressed as the sum of two angles with known tangent values. Throughout this video, we'll explore where this formula comes from, how to apply it step by step, and work through several examples, including finding tangent of 75 degrees and simplifying complex trigonometric expressions. By the end of this lesson, you'll have a solid understanding of how to use the tangent of some formula confidently in your trigonometry problems. Now we're ready to unveil the star of our show, the tangent of some formula. This powerful mathematical tool will become your key to solving complex trigonometric problems. Let me break this down for you step by step. First, let's understand what a and b represent in this formula. The left side of our equation shows tan of a plus b. This means we want to find the tangent of the sum of these two angles. Now, the right side of our equation is where the magic happens. It's a fraction with two important parts, the numerator and the denominator. The numerator is tan a plus tan b. This is simply the sum of the tangents of our individual angles a and b. The denominator is 1 minus tan a times tan b. This is 1 minus the product of the tangents of angles a and b. Putting it all together, the tangent of a plus b equals the sum of the individual tangents, divided by 1 minus their product. This formula is absolutely essential in trigonometry. It allows us to find the tangent of angle sums without having to calculate the sum first, which is incredibly useful for solving complex problems. Remember this formula well, as it will be your key tool for the examples we'll work through together. The tangent sum formula opens doors to solving problems that would otherwise be very difficult or impossible to tackle. Now we're going to derive the tangent sum formula step by step. This derivation will help you understand where the formula comes from and why it works. We begin with a fundamental definition of tangent. The tangent of any angle is equal to sine divided by cosine. To proceed, we need the sine and cosine sum formulas. The sine of a plus b equals sine a cosine b plus cosine a sine b. Similarly, the cosine of a plus b equals cosine a cosine b minus sine a sine b. Now we substitute these sum formulas into our tangent definition. This gives us a fraction with the expanded sine and cosine expressions. Here comes the key algebraic step. We divide both the numerator and denominator by cosine a times cosine b. This is the crucial manipulation that will give us our final formula. Now we simplify each fraction separately. In the numerator, we get sine a over cosine a plus sine b over cosine b. In the denominator, we get 1 minus sine a over cosine a times sine b over cosine b. Notice that sine a over cosine a is just tangent a, and sine b over cosine b is tangent b. This is the final step in our derivation. And here we have it, the tangent sum formula. Tangent of a plus b equals tangent a plus tangent b, all divided by 1 minus tangent a times tangent b. This beautiful formula connects the tangent of a sum to the individual tangents. Understanding this derivation is crucial because it shows you that the tangent sum formula isn't just a random equation to memorize. It's a logical consequence of the fundamental trigonometric relationships we already know. Now that we understand the tangent sum formula, we need to explore its companion, the tangent of difference formula. This formula is equally important and follows a very similar pattern. The tangent of difference formula states that the tangent of a minus b equals the quantity tan a minus tan b, all divided by 1 plus tan a times tan b. To understand the difference formula better, we should compare it directly with the sum formula we learned earlier. Notice how similar they look at first glance. The critical differences lie in the signs. In the numerator, the sum formula uses plus, while the difference formula uses minus. This makes intuitive sense since we're subtracting angles. In the denominator, we see the opposite pattern. The sum formula uses minus, while the difference formula uses plus. This sign change is crucial and affects the entire calculation. Understanding why these signs change requires thinking about the geometric relationship between addition and subtraction of angles. The difference formula essentially reverses certain aspects of the sum formula. The tangent difference formula is particularly useful when we need to find the tangent of an angle that can be expressed as the difference between two angles whose tangent values we already know. For example, if we want to find the tangent of 15 degrees, we can express this as 45 degrees minus 30 degrees, both of which have known tangent values. This makes the difference formula incredibly practical for calculations. The key insight to remember is that the signs flip between the sum and difference formulas. In the numerator, plus becomes minus. In the denominator, minus becomes plus. This pattern helps you remember both formulas together. With both the sum and difference formulas now in our toolkit, we're ready to tackle specific examples and see these formulas in action. Now we'll work through our first example to see the tangent sum formula in action. We want to find the exact value of tangent of 75 degrees. The key insight is that 75 degrees is not a standard angle on the unit circle, but we can express it as the sum of two angles that we do know, 45 degrees plus 30 degrees. Before we apply the formula, we need to recall the tangent values for our known angles. Tangent of 45 degrees equals 1, and tangent of 30 degrees equals 1 over square root of 3. Now we'll apply the tangent sum formula. Remember, tangent of a plus b equals the sum of tangent a plus tangent b, divided by 1 minus the product of tangent a and tangent b. Now we'll substitute our values step by step. First, we identify that a equals 45 degrees and b equals 30 degrees. Step 1, we substitute 75 degrees as 45 degrees plus 30 degrees into our tangent sum formula. Step 2, now we substitute the known values. Tangent of 45 degrees is 1, and tangent of 30 degrees is 1 over square root of 3. Step 3, we simplify the denominator. 1 times 1 over square root of 3 is simply 1 over square root of 3. Now we need to work with these fractions. We'll multiply both numerator and denominator by square root of 3 to eliminate the fractions. Step 4, we multiply both the numerator and denominator by square root of 3. In the numerator, we get square root of 3 plus 1. In the denominator, we get square root of 3 minus 1. Step 5. To rationalize the denominator, we multiply both numerator and denominator by the conjugate of the denominator, which is square root of 3 plus 1. Now we'll expand both the numerator and denominator to get our final answer. For the numerator, we expand square root of 3 plus 1 squared, which gives us 3 plus 2 square root of 3 plus 1 equals 4 plus 2 square root of 3. For the denominator, we use the difference of squares formula. Square root of 3 minus 1 times square root of 3 plus 1 equals 3 minus 1, which is 2. So we have 4 plus 2 square root of 3, all divided by 2. Dividing each term by 2, we get our final answer. Tangent of 75 degrees equals 2 plus square root of 3. This exact value demonstrates the power of the tangent sum formula. We've successfully found the exact value of tangent 75 degrees by expressing it as the sum of two familiar angles. Now we'll explore a powerful application of the tangent sum formula, simplifying complex trigonometric expressions by recognizing patterns. Here we have the expression, the fraction with tan x plus tan 2x in the numerator and 1 minus tan x tan 2x in the denominator. Let's recall the tangent sum formula. Notice something interesting. Our expression has exactly the same structure as the right side of this formula. First, let's compare the numerators. We have tan x plus tan 2x in our expression, which matches tan a plus tan b in the formula. Next, the denominators. We have 1 minus tan x tan 2x, which perfectly matches 1 minus tan a tan b from the formula. By comparing the patterns, we can identify that a equals x and b equals 2x. This means our expression represents tan of x plus 2x. Therefore, our complex expression simplifies to tan of x plus 2x, which equals tan of 3x. The entire fraction reduces to this single elegant expression. The key insight here is pattern recognition. When you encounter an expression that matches the structure of a known trigonometric formula, you can work backwards to simplify it dramatically. As a quick check, consider this expression with specific angles. Using the same pattern recognition, this simplifies to tan of 75 degrees, connecting back to our previous example. This technique of recognizing formula patterns is incredibly powerful for simplifying complex trigonometric expressions. Always look for these structural similarities when working with trigonometric functions. Now that we've worked through examples, it's crucial to understand the most common mistakes students make with tangent sum and difference formulas. These tips will help you avoid errors and achieve accurate results every time. The number one mistake students make is mixing up the signs in the tangent sum formula. Pay close attention to these critical signs: plus in the numerator and minus in the denominator. Here's what many students incorrectly write. They put a plus sign in the denominator instead of minus. This completely changes the result and leads to wrong answers. Notice how the difference formula has opposite signs: minus in the numerator and plus in the denominator. Many students confuse these two formulas, so always double-check which one you're using. After applying the tangent formula, you'll often get complex fractions that need simplification. Don't stop at the raw formula result. Always look for ways to make your answer cleaner and more readable. The key simplification technique here is multiplying both numerator and denominator by the conjugate to eliminate square roots from the denominator. When your final answer has square roots in the denominator, you need to rationalize. This means eliminating the square root from the bottom of the fraction. Multiply both numerator and denominator by the conjugate of the denominator. The conjugate of 2 minus square root 3 is 2 plus square root 3. The denominator becomes 4 minus 3, which equals 1, giving us a clean, rational result. This is the power of rationalization. It transforms complex expressions into simpler forms. Here's a simple memory aid. For some formulas, you add in the numerator but subtract in the denominator. For difference formulas, it's the opposite. Remember the phrase, sum subtracts, difference adds, referring to the denominator signs. Before submitting any answer involving tangent sum or difference formulas, run through this checklist. Verify your signs are correct, simplify your result as much as possible, and rationalize the denominator if it contains square roots. Following these steps will help you avoid the most common errors and achieve accurate results. We've reached the end of our comprehensive exploration of the tangent of sum and difference formulas. Throughout this video, we've covered the fundamental concepts that form the backbone of advanced trigonometry. Let's recap the two essential formulas we've mastered. The tangent of sum formula allows us to find the tangent of the sum of two angles, while the tangent of difference formula helps us find the tangent when we subtract one angle from another. We've accomplished several important learning objectives in this video. We derived these formulas from the fundamental sine and cosine sum formulas, showing you the mathematical reasoning behind them. We've seen how these formulas serve as powerful tools for finding exact trigonometric values for angles that aren't directly available on the unit circle, such as 15 degrees or 75 degrees. We've also demonstrated their effectiveness in simplifying complex trigonometric expressions, making seemingly difficult problems much more manageable. Most importantly, we've highlighted their essential role in advanced mathematics, including calculus, physics, and engineering applications. These formulas have widespread applications across multiple fields. In mathematics, they're crucial for solving complex trigonometric equations and proving identities. In physics, they help analyze wave interference, oscillations, and rotational motion problems where multiple angles are involved. In engineering, they're used in signal processing, structural analysis, and control systems where trigonometric relationships are fundamental. To truly master these formulas, I strongly encourage you to practice with different angle combinations. Try finding exact values for angles like 15 degrees, 105 degrees, or any combination that interests you. Remember, mathematics is best learned through practice and application. The more you work with these formulas, the more intuitive they'll become, and you'll start to see the beautiful patterns and connections throughout trigonometry. If you found this video helpful, please give it a thumbs up and subscribe to our channel for more comprehensive mathematics tutorials. Your support helps us create more detailed, step-by-step explanations like this one. Don't hesitate to leave comments with questions about specific problems or requests for future topics you'd like us to cover. We love hearing from our viewers and creating content that helps you succeed in mathematics. Keep practicing, keep learning, And remember that mastering trigonometry opens doors to advanced mathematics, science, and engineering. Until next time, happy calculating.